Hey, how you doing, man? Um, can somebody who's part of my sub crew please jump into the Discord and check that the link that I posted actually works before I send it out as an email? Because I can easily fix the one in Discord. I can't easily fix the emails. Awesome. Is that how you got here? Through the Discord, or the link works? I used it. Awesome. All right, I'm gonna just flick that out through Blackboard as an email. Send a copy of this announcement. We should be good. Where's my stream? There it is. Awesome. How does layout look on screen for you? I think I moved a couple of things around, like the chat window and where my head is and stuff. Does it look still all look good? Thanks, Fletcher. Awesome. Sweet. ES inductions up. So I'm doing screen capture so I can show you. Hold on. Go to Blackboard. Go to Blackboard. Go to my site now. So don't do this one. This one is still broken. Go to my site. Go to inductions. And follow the bouncing ball. ES126 induction. Manual. Watch these videos. I got them made this week. They're pretty cool. And then the quiz is down the bottom. Okay. So I am going to talk about it in this stream. Because, yeah, obviously people need to know this. So do that. Hold on, PowerPoint and see if you can find it, Jeremy. Just to make sure that if I do that again to 600 people, that's everything they need to know. Just see that you can get into it and it works. We're not going to start for a little while, so you got time. I'm going to edit this real quick. How's everybody else doing? Everybody else done their inductions? Any other admin-y like questions and stuff like that? If there's anything else that we can kind of work out now that I know hundreds of people are gonna want to ask me in a minute, I might be able to really quickly prep some content or something. I hope everybody's keen for their workshops. I hope people are starting to enjoy them a little bit more now that they're less admin and more actually learning cool stuff. Done inductions? Nice. Red Sox, what other inductions did you do? You only need to do the one. You're going to be inducted everywhere. Hey, glad you liked the lecture. I really like that lecture. I think it's a really cool way of looking at content. Software don't have any inductions. You're easy. OH&S for software is like super chill. There's nothing you have to worry about. I don't know. Eye strain is probably your biggest risk. Sick. The induction works. Awesome. Thanks, Jeremy. Warpacks, what project are you talking about? Because some of them aren't up yet. Uh, Robert, do you want us to wear our safety gear to the workshop this week? I, I want you to bring it. You need it next week. You're not really going to use your safety gear this week, but we would highly encourage everybody to bring it. Kind of have your workshop leader look at it and be like, yes, that's all okay, you're fine, rather than you show up next week and us say, no, that type of safety glasses is unacceptable, you're not allowed in, but you shouldn't need it this week. Do you know how we organize the 3D printing induction for the makerspace? No, I don't. I don't use it. I have access to a different set of 3D printers in engineering. I don't know how you do makerspace. It wasn't a thing when I was here, so but I did talk to some people about building some makerspace inductions for 2110. I will find out for you. Okay. Awesome. Thank you, Red Sox. Look, the one that's on my Blackboard site won't take you very long. RSI for softwares? Yeah, no, that's true. That is true. Mecha. Alright, so Warpacks. The robot project description isn't up. It is finished, but it's not up. We changed a fair bit of it this year, and we changed it pretty late. So there's a few things that need to be right in it before it goes up, and actually I want to make a video that introduces it to go along with the document, just to make sure the goal of the projects in previous years has slightly shifted. And I know that there's a lot of people who come into this project with preconceived assumptions about what they're doing, and I want to clarify some of that. So you will get a video. It will probably actually go along with next week's lecture that will kind of really help exactly set the scene for you. Sorry, I know it would have been better if I could have had it to you earlier, but I want to get you something. I think I can get you something better if I take a touch more time. Also, I'm just going to kill that so you don't keep getting weird noises coming through. The stress of a modest office has sent you into depression. Look, fair. Interesting point. Whilst we spend a huge amount of time talking about workplace health and safety, one of the biggest dangers for a young person, not right now, over the last quite a long time, actually more dangerous than any type of accident is poor mental health. So it's like a fully realistic point is addressing the mental health of employees has now become like a major concern. And people making depressing offices is a really bad thing. Hey, I'm glad you like the lectures, Harry. Put a lot of effort into trying to make sure they're not um, terrible. Is the decibel an SI unit? No, it wouldn't be an SI unit. I don't think it would be a derived unit. But it would be an absolute mess, and the decibel scale is a mess. It's horribly complicated. It's a really good example of something like an imperial unit. If you try and get to sound from a very scientific approach, it's very hard to do anything useful with it, but the decibel scale is a really good imperial scale of basically how things sound to a human. But it's hard to do science with that. For medical, making the ECG for one specific person or for any person. Just a little confused after watching our degree specific videos. Yeah, so a lot of that is going to be up to you, and a lot of this style of question, what exactly is the end goal of your project, is a large part of next week's lecture. And it's all about identifying a target market and building a solution for them. So the duality here is that if you make a product that's general and is supposed to help everybody, then it probably doesn't help any one particular person very well. And if you make a product that's super customized to one person, great, but does it help anybody else in the world? So how do you thread that line of appealing to the correct target market? So this is where you're going to work with your client and talk to them about this, but you're also going to do a lot of problem identification to try and figure out exactly what is this thing supposed to solve. And you will come up with, all right, I'm going to make an ECG, for example, that any person on earth can put on, and it's going to be really generic, and that could be perfectly fine. And another team might come up with, all right, I'm going to make something that's directly targeted at elderly people with a known heart condition. And that's going to partly be up to you. Don't worry if you're confused. You should be confused. You should be asking questions about that right now. I haven't seen The Office, which is kind of surprising because I really like that style of show, but I've never actually seen The Office. When watching lecture 2, you were right about the engineering studies using 10 as gravity. Just make the maths easier. Yeah, it's not the worst assumption when you're making trusses and stuff like that. You've got far bigger assumptions. You may as well make the maths easier for yourself. We'll be notified of assessments coming up during lectures, workshops, or these Q&A sessions. Lectures. So that's another thing that we will talk about in a little bit. The way that I'm going to do this is with a lecture with everything kind of hanging off it. So you'll get a lecture. I'll probably briefly talk about your assessment. I will then make an assessment specific video that will be in the video that I'll put in the video description of that lecture. And that's how you'll get to content from now on. Okay. It's better than having scattered videos all over the place. You're going to get all of this laid out in video descriptions. And that way, what you do at the start of the week is go to your lecture. Watch the lecture on the weekend, and then it will have everything you need in the video descriptions below. You'll still have dedicated workshop content in your workshops, but everything coming from me will come out of that lecture. Are we in the age of refinement rather than invention? I would say no. I would say we've gone around in a bit of a loop, and we constantly do as the race go around in a big loop where you have big ages of invention, and then, yeah, I would call an age of refinement, and I think we're very much going back into an age of invention. Startup culture and global addressing issues at a global scale, like energy and feeding people and battling pandemics, things we do at a global scale, are requiring invention, not refinement. Are these live streams exclusively Q&A? No, we're going to go through some contents, and I'm going to try something a little bit new this week. Heath, ES induction quiz is just the short 10 questions, get 100% and you're done. Correct, get 100% and you are done. Do we need to have the induction done by this week's workshop? No. You need to have it done by next week's workshop. If you can have a go at it this week and just check that it works, because obviously it's been so broken for so long, you should try and do it this week and just see if you have any issues. I've not watched Silicon Valley. My housemate and the guy I founded my company with did, and he thought it was very funny, so I should probably watch it. All right. It's 5 past, so let's just really quickly, we're in, we've got viewers. All right, sweet. So I'm going to jump in, I'm going to go through some content, and we'll cycle back to some Q&A. Hold on, I made a slide for this. All right, so we're going to do some housekeeping for a while first and cover all of these things. I'm already getting questions about inductions and stuff like that, so we're going to go through that together. I'm then going to deliver a bit of content. I'm going to do it in a way that I haven't done before, and I want to try it, and I want to get your feedback on whether this is a useful way of doing this. And then we've got Q&A for the rest of it. So, bits of housekeeping first. The way in which content is now going to come to you is going to be, and if you had a look at this week's lecture already, it's a big lecture, and then in the video description is an enormous amount of content. That's how this course is going to go from now on. So I want you to be able to come in, watch the lecture first, because that's what you should be doing first thing each week. It should then have, as required, some weeks it will have discipline-specific components that you need to watch. And if it has something like an assessment task, it will be linked in that worksheet, in that description. And if it has a worksheet, it will also be linked in that description. So you no longer have to go to Blackboard, get a worksheet, fill it out, watch the lecture, go and find a different video that's hosted somewhere else for your discipline-specific stuff. You don't have to do that. You go to the lecture and you consume 100% of that content. Some of this content will be duplicated in other places, but I'm trying to just condense it all for you to reduce your cognitive load of where do I have to go to find all this crap. Go to the lecture, watch it, look at the video description. That does mean when you open video descriptions, they're going to be huge and they're going to be messy. Don't freak out when you see that, okay? So that's my strategy here. I'm going to try that. That seems to work better than any other strategy. Also, do your assessment task. Is anybody in the chat who hasn't started their assessment task yet? Because it's going to disappear in a couple of days and then you're not going to get any marks. Also, loads of people don't have 21 out of 21. They've attempted it and they don't have 21 out of 21. So if you don't, you can do it again until you get 21 out of 21. So please do your assessment. I made it as easy as I could, but if you haven't done it by Monday of next week, then you aren't going to get to do it. It's just going to disappear. All right, and I finally fixed the ES126 induction. All right, I think. And from the people in the chat so far, they seem to tell me it's fixed. So what I had to do was I put a bullet in the old one, and I'm not going to use it anymore. The new one is now contained within my Blackboard site. So what you need to do is go to Blackboard, however you get to Blackboard, go to Blackboard, go to my site, okay? Don't go to this one. This one doesn't work. Go to this one. Click on this, and you've now got an inductions tab there, okay? Click on that. Now, these are both hidden. This is the EE and the RB. I can't actually host those two things. I was trying to figure out a smart way to do it, but I can't, so you won't see them. You'll just see this. Click on this. And then you've got the induction manual, which is all a Word document with all the information you need to know. And I got a few cool videos made. So watch these videos. They're from a guy who is both a tradesman and an engineer, and I asked him to make some videos that are appropriate for your level. And then the quiz is down the bottom. These videos, you don't need to be in ES126 to watch them. If you want to learn a bit of that stuff, if you're in the architecture workshop, if you just want to know it, please watch them. And they are meant to be here for you to come back to later. So in a couple weeks when you start designing and building stuff, maybe come back, watch these videos again. Hopefully they're a useful resource to you. So let's pull that up. New tools induction. Yeah, so in the inductions tab within the ENGG1500 Blackboard site. Don't do the other one anymore. It still doesn't work. Attending your weekly workshops is important. Don't freak out if your attendance app doesn't work. I care more about whether you attend than whether your app logs that you attended. But it is quite important that you're attending your workshop every week, and you are there on time, because you're going to start in the future working as a team, and you're going to be expected some days to start from the beginning of class. So you need to be there, you need to be on time, particularly when you're working with your clients. If I'm going to pull somebody in from industry and you're going to walk in late, that's not a good look for you. Okay? So just try to make sure. I know it's really hard in week one, but try to get on top of being on time to class. It is really important. Okay, I sent this out. The robot project has got a couple bits of admin. No, you don't have a project brief yet. Yes, you will get one very, very soon. Robot kits, they are missing a few parts. The kits you got in week one. We've since got a new order in. We can now collect some more parts and you can assemble your bots. So you've got 2 tasks over the next week for anybody doing the robot project. Part 1 is assemble your kit of parts into a functioning bot, and then the other part is do the week 2 lab. I don't care what order you do these in. Well, actually, no, I do care what order you do them in. You have to assemble the bot before you can do the lab. But depending on where your workshop is, which one you do in the workshop and which one you do as a group outside of the workshop, I don't care. But you're probably better off to come and get the parts off me tomorrow if you can, assemble your bot, and then do the lab, just because you'll need help with the lab and your workshop leader will be there. So, ES126, I'll be down there because there's other classes on from 2 to 6. Come, knock on the door, ask me what parts you need, and I will direct you. Alright? Oh, anybody who's not in the Discord will need to email me for a link now. It is currently closed, because anybody who's not in now, I'm really worried about and need to talk to, because somewhere the wheels are falling off and we need to make sure that things are going to be okay. Alright, so live lecture recap content. This is something slightly new I want to do. I'm going to try this. You may have noticed that I said in the other lecture that I used to do quite a lot of it live, and it was a big aspect of that lecture was getting input from you and me sort of playing that to try and show you more about how models and assumptions work in a less structured environment. So what I'm going to try and do over the next couple of weeks, and I want your feedback on whether this is effective or not, is put another example into this live stream, and I'll try and do some parts of this live with you in the chat. And hopefully that way I can reinforce the key points of the lecture, and you can get a bit of involvement and hopefully learn some stuff a little bit more. So this will assume you've watched the lecture, all right? So my expectation is by the time you get to the live stream, you've watched the lecture. That way you can, you know what I'm talking about in this environment, and you can get involved in this chat. I'm going to chuck some multiple choice questions in as well after this. I don't know if this is going to be engaging, but let's try it once and we'll see how it goes. And the idea is to, reinforce our key ideas. I'm also going to start to blur the lines between what we talked about last week and what we're going to talk about next week. And hopefully if we can do this nicely, you'll then be super well prepped for next week's lecture and it'll make a lot more sense to you. All right, so our models and assumptions thing. What I've got here is an example that's taken from my company, essentially. So something that we've done several times in our company is worked with other people, because we make, I should remind you, we make thermal storage materials to store energy as heat. So something like the power you create through the day from solar panels, if you want to use that at night, you can store it in things like electrical batteries, but they don't scale to large things very well. You can store it as heat far more cheaply. And lots of different people have different technologies out there for storing energy as heat. So we make a new type of thermal storage material, and we work with other people who make steam turbines and generators and all sorts of different stuff, and they generally ask us for demonstration devices. So what we need to do is create some sort of vessel to house an amount of thermal storage material and demonstrate that it can be heated up, store energy, and discharged. Okay? So that, what's on the screen up there, and basically that, demonstrate the thermal storage capacity of the material, is a project brief we get given all the time. We've done it like 5 times now. So what I want to do is go through this with you. What can you see in terms of models and assumptions in this case? And what questions do you have? Because you probably have some questions here. So if you think this through, if you can try and think this through, what can you think about that you would need? How would you see this thing being designed, and what types of models would you think you would need to be solving in order to do the design of this containment vessel? What questions would you have? So mirrors and salt are one way of doing this. It's not the way that we do it, but it's the way other people do it. Models of thermodynamics. What models? How much heat? How much heat's a great question. And how is it being heated? All right, cool. So this is good questions about the thermodynamic side of this. The way in which this particular one we're going to talk about today is heated is I'm going to flick through and I'll show you a picture right at the end. Oop, that one. So these are the thermal storage blocks, and this is a pipe that will get filled with a heat transfer fluid. And they'll pump it in, so they'll heat it up first and pump it in, and that will charge the blocks. And then when they want to discharge the blocks, they'll cool that fluid down and pump it in colder, and the blocks will heat the fluid up. Oh, where's my slide? There we go. How far is it being transferred? What do you mean how far? Is this how big the box is? Because that's an excellent question as well. Specific heat capacity, yeah. So specific heat capacity is a great one. You're talking here about how much energy storage we can do. So how much energy will a kilo of this thing store? And it will store energy in 2 ways. It will store it as it heats up, and it will store it as particles in this thing melt. What's really interesting about specific heat capacity from a modeling perspective is you'll often see it and you'll get given a specific heat capacity, and the answer will just be like 4.16, the specific heat capacity of water. That is true only at a particular temperature. Specific heat capacity actually changes as you heat something up. And obviously you can't store energy without heating something up, and your specific heat capacity constantly changes. So if you've ever seen specific heat capacity and you're giving just a number, that's a huge assumption that you're working roughly around a tight temperature range, which is not true. How much heat is being lost through the container? Yeah, this is really good, and it's really important. How much heat is being lost? It's important for 2 different reasons. How much heat can you afford to lose? Because that's a loss, right? If I'm going energy in and then energy out, but I'm also losing out of my container, well, how do I compensate for that? So how much is getting lost? How can we measure that? How can we limit that? And what's an acceptable margin on that? Because you're never going to stop all of it from being lost. How do you convert heat to electricity? Yeah, so this is a good one on our end, is we don't do that. So we work with somebody else who makes turbines or power systems or whatever. And this is constantly a thing that gets passed back and forth between our company and somebody else, and it's like, yeah, we're farming that out to you. and occasionally it's a real problem. The way in which somebody converts heat to electricity does actually dictate a lot of our decision-making process, and a lot of the time that's not communicated well. It's a big assumption. Fluid flow under temperature and pressure. So not just fluid flow under temperature and pressure, but also how well does it, if you put a fluid of a particular temperature through a pipe, how does it transfer heat to that pipe is super important. And there are unbelievably complicated models for this, especially if you've got boiling going on. Any leakage? Yeah, so leakage was a big one for us. These fluids in general that go through the pipe are not things that we want to touch our thermal storage material. It would destroy it really, really, really quickly. So this was actually a little bit of a sticking point for us, is what happens if the pipe breaks? And is it our job to design a containment vessel that can deal with a pipe that breaks? We don't supply the pipe in this case, we're given it. If it's not to spec, is that a problem for us? Or do we just let the whole thing go up in flames? Whose job is it to take care of that is a massive, massive constraint. How much maintenance does the system need? Excellent question. To go along with that, what's the design life of the system? That was one of my first questions, is how long is this thing meant to last for? And that then totally dictates the maintenance schedule, right? If it's meant to last 100 years, then it'll need to be maintained, and then we need to design it in a particular way. If it only has to last 10 minutes, well, that totally changes that problem. What is the material? What is which material? You've got a pipe made out of a nickel superalloy. You've got our thermal storage material, which is a proprietary alloy that we don't tell anyone. We do, but only after they sign a commercial in confidence. You've got an insulation material somewhere, and you've got a containment vessel that you're going to make it out of. The material selection process for every one of these things need to be completed, and also how do they talk to each other is super important. Where does the container need to be located? Excellent question. This is to go on to somebody else's test rig. So somebody else has made a rig that is used to test thermal storage materials, and we need to interface with that. Rate of thermal transfer to the block. So there again are great models for this, and there's a thing called thermal shock. If you heat something up too quickly, if you heat something up too quickly, you can break it, you can crack it. So there are models for the rate at which you can heat up a lot of materials before they shatter. If you get a piece of ceramic, it's like 5 degrees a minute. If you get a piece of metal, it's thousands of degrees a minute. Our materials are a mixture of a ceramic and a metal. We don't have a model for that yet. We don't know the answer. So that's another one of those things. We don't have a model for that. Is there a requirement of the storage of the containment vessel, store at a specific temperature? Yeah, so what's the operating temperature? So a bunch of the models that we're talking about are functions of temperature. What's the operating temperature? 700 degrees. Now, was that what you were all thinking? And does that change how any of these models may work? Because if we look at our models for heat transfer, there are 3 ways that heat is generally considered to transfer from one object to another. Conduction, you can conduct along a path. Convection, you can have a gas that moves, or a gas or a liquid that moves heat around. Or radiation, something heats up and it glows and it emits radiation. These vary in importance based on temperature. So some of them are predominant at low temperatures, some of them are predominant at high temperatures. At 700 degrees, out of curiosity, what do you reckon the most important one to us is? Okay, what is the fluid? And this is going to go with a couple of other points I've seen. What is the initial temperature of the fluid when it reaches the blocks? So depending on who we talk to, this can be water, steam, supercritical CO2, so carbon dioxide, or liquid sodium. And some of these things are really important because it totally changes the heat transfer characteristics, whether it's a liquid, a gas, a supercritical gas, or something that is boiling, changing phase. So all of the models that you use for boiling are not applicable to something that's totally a gas, and they're not applicable to a liquid. Also, some of them have minimum temperatures. If liquid sodium gets below a particular temperature, it ceases to be liquid sodium and it becomes solid sodium, and you can't pump that. So we have to put internal heating within the structure to preheat it to a particular temperature so that we don't ever solidify the material that we're using. So that's a great point. The stock standard generic assumptions that we use may totally ruin us in a situation like this. Human safety around it. Hot is dangerous. Great point. What is the maximum temperature the outside of this box can be? Where's it being tested? I asked literally this question. Where is it being tested? What are the safety precautions that go with it? So if you know your internal temperature is 700 degrees, you can get, we talked about this before, how much energy is it allowed to lose, and what is the maximum temperature of the outside wall allowed to be. And if you can fix two of those three, you can then build a model and you can calculate the third one. We did this. No combination of these three things that we were given in our brief was acceptable. So we were spec'd an internal temperature and external temperature. You need a thickness of insulation and a heat loss. And it was actually impossible based on the modeling that we did. So we actually got to go back to them after 10 minutes of modeling and say, this is actually impossible. All right, this is awesome. Kelvin or Celsius? I was talking Celsius. Great point. 700 degrees Celsius, not Kelvin. Awesome. So, all right. These are so good. This is so... okay. I'm really glad I did this. This is excellent. What you're putting in here is excellent. These are really, really good things to think about. I want you to take this type of logic into engineering problem solving as well when we do it. So I'm going to flick through some things really quickly here. This is the stuff that I jotted down. So maximum temperature, minimum temperature, operating temperature. And it totally dictates what heat transfer models we use and the way in which our fluid works. So you guys absolutely nailed that. That was awesome. I did see this in the chat, and I don't know if I got to talk about it, but controlled atmosphere. What atmosphere needs to be in the box? Will these things burn at 700 degrees? And the answer is actually yes. Kind of, sort of, a little bit, because they'll make their own atmosphere when they do burn, which will prevent future combustion. So what atmosphere and how that works are really important. Also, if you have any gas inside of your vessel and it's airtight, as you heat it up and cool it down, that gas is going to want to expand and contract, and that can create pressure, which could create an explosion. So we talked about insulation requirements, and that was really, really good points. People were talking about what's the maximum external temperature, how much heat transfer is allowed. You guys totally nailed that. We talked about convection, radiation, and conduction. I didn't see too much of this, but maybe I just missed it. But what are the requirements of the outer casing? How heavy is this thing? How strong does it need to be? Is it just there to hold the insulation in, or is it there to actually support some real strength? And does that totally dictate what it can be made out of, how thick it needs to be, how it needs to be welded together, and whatnot? We got a little bit of this. People asked about the pipe. Something we haven't spoken about yet. Thermal expansion models. So as the pipe heats up, it's going to thermally expand, right? But if we remember our picture, I'm going to see if I can find it again. No, where's my picture? There it is. I don't know why I did that. Okay, whatever. This pipe is going to expand more than this block that's around it. So that could, and does in lots of systems, cause them to break and fail. So there's models for thermal expansion that are kind of valid in this scenario that maybe will cause us problems. Okay, so this is a good one because this is a model that we don't have yet. How do you measure the temperature internally? In this case, it's normally measured with things called thermocouples, and they're these bimetal probes that you stick into something. And they create a small voltage, and then you can read that voltage, and if you know the material properties, you can infer temperature. So there's a whole bunch of models there. But what's more important is if I've got a material and I want to know how much of it is solid and how much of it is liquid, how do I figure that out without, I don't know, cutting it up and weighing it? We don't have good models for this, and it's actually something that we spent a whole bunch of time, and a bunch of people literally flew to other countries to put things inside of nuclear reactors to bombard them with neutrons to try to calculate what we call a state of charge. From a temperature measurement, can I infer how much of this is liquid and how much of this is solid? It's really hard to do, and it's an unbelievably complicated model. And we got design life. So we addressed that. Okay. Awesome. Amazing. This was really cool. This was obviously a lot of really good questions. I hope that this helps to reinforce a few of the things that we saw in the lecture to go, okay, this was one problem, and we're talking about what? Out of your comments, probably 50 to 100 models, all of which are based on assumptions, all of which would need to be validated before we could actually work with this. And these are the assumptions and models that you will learn throughout your degree, okay? Depending on what field you're in, you will learn more of some than others. The electricals will learn more about the measurement and the control side of it. The civils will learn more about the structural integrity. The chemicals will learn more about the thermodynamics, but that's fine. And this is also one of the reasons we work in teams. Because you can see, my problem was make a box, and we just blew it out to this enormous engineering problem, right? So this is why we've got to make models. We've got to understand their validity. Cool. All right, so I want to switch away from that, and we'll switch into some unit stuff. But before I do so, can I just get from you, I did not mean to do that. Do you think that was useful? I thought that was really cool, but was that an engaging thing to do? Do you think this is something that we should try and do week to week in this live session, or is it better to just do Q&A? Also, cool beans. Sorry, I just was a little bit worried. Okay. I feel that that is fairly conclusive evidence. All right. Sick. Well, I'm glad I stayed up to 1 a.m. putting that together last night then. Awesome. I will do this every week I can now. I will build some example into our weekly live stream directly based off the lecture content. There may be some capacity to try and do this with more specific project related things, particularly in the future. Maybe we'll try and run one of these and we'll throw project briefs up and people can rip into project briefs. I don't know. We'll see how we go. All right. So switching out of models and assumptions. Thank you, by the way. Thank you for the engagement. That was amazing. Switching out of that, let's hit some highlights of units. I don't know if this is a fun way to do this or not. Again, I did this really late last night. Chuck the answer in the chat. What is the correct SI unit for distance? I know that there are apps and stuff that you can do this kind of jazz with, but I don't think we need that level of complexity. I mean, I'm happy to. I'm happy to build this as a quiz and, have a link in the description. All right, cool. We're good. We got the first one. We got meters. That is correct. Well done. All right, next slide. What about mass? There was actually a really interesting chat in the Discord because somebody asked this question about weight, and there was a cool discussion about weight versus mass and the units of them. All over it. My trick question didn't get anybody. I was thinking that I was trying to set you up to answer Graham here, but Yeah, you're all over it. Kilogram is our SI unit for mass, and it's a weird unit because it's the only time where something with a prefix is actually the SI unit. In general, the rule is it would be the gram, right? It's not the kilogram, it's not the milligram, it's just the gram. But no, in this case, for some reason, kilogram is the unit. All right, slightly more difficult, more subtle. Be careful. Look at the subtleties. What's the correct answer here? Didn't make him hard enough. Yes, very good, very good. Ah, I got a couple of people with C's. The correct answer is D. Awesome. All right. So this is subtle, and this is something that if you didn't watch the lecture, I would have expected you to struggle with. So the correct answer is D. So we've got two variables here, right? Um, capital K or lowercase k. In general, if a prefix means bigger, it gets a capital, with the exception of kilo. That's the only one that doesn't get capitalized. Mega, tera, giga, whatever, all get a capital, except the K in kilometer or the K in general in kilogram or whatever is lowercase. Okay? So it's definitely B or D. We can do a 50-50. It's definitely not this because the K for some reason is lowercase. And then the answer, the distinction is it a space or is it not a space? It is a space. I know that's not the way a lot of people like to look at it, um, but it is the correct way to format it. And the reason being is this is an abbreviation for a full word. So you wouldn't write 12 kilometers without putting a space between the 12 and the kilometers. So you don't write 12 km without putting a space. So that is the correct formatting. These are probably the two most common issues that I see from formatting from first year, so I thought I'd chuck them in. All right. Finally, what's your correct formatting here? I think this is the last one. Kilo is feeling special. Yeah. Yeah. I mean, this was exactly in the lecture, so if you can remember that slide, you'll be all over it. Nice. So the rule I'm hitting here is named after a person gets a capital, not named after a person doesn't get a capital. Yeah. Newtons, named after Newton. Meters, I don't think there was somebody called Meters. Oh, Watts, named after Watt, steam engine guy. Seconds, don't think there was somebody called Seconds. Awesome. Okay, so that's all I had. I just wanted to hit a few of the highlights from that lecture. I know with stuff like the units, I did a whole bunch of weird distractions and interesting side points, but I thought it might be useful to just sort of condense some of that useful information into this and just re-hit it so that it was... These are the things I want you to take away, all right? So when I mark one of your assignments, the things I'm going to look for is you never use centimeters. You could use meters or millimeters, but you never use centimeters. I want you to know how to do this correctly, where to put your spaces, and I want you to know which units to capitalize. They are the things that I'm 100% going to look for whenever you write anything down and give it to me. So, cool. Couple of questions. So, should I do this again next week? Was the little multiple choice game also interesting, or is that something I should do more of or less of? Up or down, yes or no? More or less of that? Okay. I mean, they're only going to be 10 minutes. So if it's, I guess, the thing that if it's not super exciting, it's only going to be like roughly that long where I try to hit some things. But if, cool, it seems to get a bit of buy in. So we'll play some games. I could make surveys for this. Why I didn't want to make this as like a quiz and a survey is I didn't want you to have to also log into a thing. I don't know if that was extraneous cognitive load or not, but yeah, like I mean, we could definitely do polls, but I'm not sure what the added learning benefit to you is of having a poll. I can try one next week and we'll see how we go. Tilly, did you watch the lecture when I put it out at like 11 o'clock at night? Awesome. Yeah, sick. All right, so I think I've got a bit of a better structure for my live streams. I'll come on early. We'll do Q&A. So if you have desperate questions you want to get out of the way, get on before 8 because I'll be on by like 10 to 8, quarter to 8. Smash all of your immediate questions out. Then we'll do this for a while, which will hopefully be fun, and then by about 8:30, 8:40, hopefully we'll back to Q&A. I have one final question for you. For those of you doing Mech 1110, apparently I was told that you may have some interest in obtaining a Discord for Mech 1110. I've got my person who makes Discord is aware of this, who made my Discord for me and set it all up with all the roles and stuff. I just wanted to know what you want to get out of a Discord channel. You don't have to. Feel free to chuck it in the chat. You can also talk to me offline about it or through my Discord. I would assume you want something that looks more like the ENGG1500 Discord than looks like mine, but I don't know. Let me know what you want out of your Mech 1110 Discord. Why do you want it, basically? Because A, I'm curious about why there's such buy-in into Discord. I know it's great, but I want to know why you think it's great. And I want to know what you want to get out of it for Mech 1110 so we can build you something that works for you. Okay? Obviously, remember that Discord is never a replacement for Blackboard. It's an as well as, not an instead of. Um, so don't feel just because there is a Discord that you would have to buy into it. If Mech 1110 makes a Discord, it's not that that'll be the only place to go. It'll just be supplementary places to go. All right, and then other than that, we're just into Q&A. Okay, so Q&A in the chat. What do you want to know? I've got an hour and 17 minutes, and I'm happy to answer anything I can think of. Different channels for Creo. Okay, Jasmine, good question. So this is the mechanical project. You're talking about the wind energy conversion device. So Sean is your workshop leader, mentioned the reduced efficiency during bushfires. Do you need to design for those types of things? We're going to do some problem definition stuff next week. Your first prototype, maybe not. But you should definitely build it into your design thinking process and use that to kind of push your ideas out. So would this idea work in a bushfire condition? What would you modify to make sure that it does? Can you easily build that into your solution? Is there some part of your solution that fundamentally fails? If you've, I don't know, got a solar panel to make the thing start, that may not be a great solution there. Are we going to fill the wind tunnel with smoke? No. But would it help you to be able to discuss these aspects with your client? Yes, very much so. And that could be your sell. If you're the person who's thought of that and your team creates a solution that works super well in bushfire conditions, amazing. Sell that thing to your client. Okay? And that'll go for everybody. Update the weekly schedule on Blackboard. Yeah, I can do that if I need to. The issue with the weekly schedule in 1500 is it's different for every project. So in my lecture, I gave you what your next 6 weeks of lectures are going to look like, but for your projects, everyone is doing something different. So I try and cover that in lectures. And yeah, it's no one Blackboard site can have all 10 projects in it in a useful way. But if you can let me know specifically what you want that updated for, I can start to put that specific content into these descriptions for you. Is there an induction for renewables? Yes, it's the RB workshop induction. Go to Blackboard. So this is chemical and renewable. Go to Blackboard. Anybody doing the solar D-cell project with Simon? It's this one, okay? Architecture and Built Environment Workshop. Now, there's a whole bunch of levels to this, and I think you only need to do the stage 0 induction. Think you only need to do stage 0, all right? I don't think you need to do any of these yet, but you have to do the stage 0s, okay? So do them as soon as you can. And again, ask Simon and or Paul and or Oscar in your workshop, and hopefully they will be able to help you out. So my lecture PowerPoints are like full green screen slides. They're awful things to look at. I attempt to timestamp my lectures such that, so my logic here is okay, why don't I upload slides to Blackboard? The reason is, when I looked at this a couple of years ago, people would upload slides and it kind of helped with student engagement and learning. But what was found to be far better was, instead of uploading slides, was to ask them a series of questions to get them to think about before the lecture started. Give them the lecture and then do a recap of the lecture a couple of days later, highlighting key points. And that was found to be much better for students to learn the content. So literally this week, you got a worksheet with your lecture, you got the lecture content. I timestamped the bejesus out of it so that you can go back and use it as a study reference. If you want to flick through quickly, you can go to the timestamps. And then we do Q&A. My lecture slides, because they're all pictures on top of pictures on top of pictures on top of a green screen, are atrocious to look at. I don't conceptually have any problems uploading them, but I don't know how useful they're going to be. But I can, if people want them uploaded, I can start uploading them. Yep. So again, what you need to do each week, if it's from your workshop leaders will tell you, and if it's from me, I will tell you in the lectures. Okay. So that's where you'll be able to keep up to date. I can chuck some stuff up on the timeline, and I will update that. It should already have the assessments on it. Take me to the home page. Yeah, it does. It's already got it. Watch weekly lecture videos, attend weekly workshops. Your quiz is due here. So it already has that in it. There's nothing more than that that's not workshop specific. And yeah, every one of the 10 workshops has totally different things that it needs you to do each week. So go to your workshops, talk to them, and they should be able to help you. No amount of generic information out of something like this is gonna help you, unfortunately. It is a bit of an issue with this course that is a little bit confusing because everybody's doing different things. I've tried to standardize it a little bit more this year. But yeah, it's a little bit tricky. Listen to your lectures, listen to your workshops, and then ask me as you have questions. I will do my absolute best to help you wherever I can. Huh, that's interesting. Rob, will those models and assumptions questions always be to do with civil chemical problem briefs? I don't. This was a mechanical project brief. I'm a mechanical engineer. That was a real problem for me as a mechanical engineer. I did not see that as a civil problem or a chemical problem at all. To me, that's a mechanical and a control problem. So it's an electrical mecha and a mechanical engineering problem. That's really interesting. So no, I will pull them from real life examples um, that I have experience with because I can't talk. I can talk with authority on something that I have experience with. So they will probably have a mechanical bias, if anything. What do you recommend doing between now and our workshop? What project are you? Possibly nothing. For the Enviro workshops, you will need steel cap boots, safety glasses, and a set of work gloves. Okay. If you look, Sophie, it's the same as anybody for ES126. Okay. So you just fall in the same boat as ES126. So all the mechanicals, civils, aeros, and enviros, you now all need the same suite. You all do the same induction. You all need the same gear. Steel caps, gloves, safety glasses. And then just clothing that's sensible, long hair tied back. Yep. All the assessments are in the thing. All the assessments are up. Assessment, 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 assessment. They're all there. Okay. Um, but to clarify for you, because this is important and it will happen next week, whenever you get an assessment, you'll get a video from me explaining what it is, how it works, what my learning goals are with it, so you understand the timeline. But in 1500, we do continual assessment, so as you can probably tell by this thing that's laid out up here, assessment, 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 you've constantly got one going on. And realistically, this one is actually a small task every week in your workshop. Okay? So it's all laid out. As you actually get these assessments, I will talk to you about them more, but it's all up there in the Blackboard thing. But don't worry, I will give you heaps of content when I actually issue the assessments to you. Your timeline says nothing. Really? That's strange. You can't see them. Huh. Okay. Alright. What? Why? I have no control over that timeline. I don't touch it. Also, okay, I don't understand why the timeline is broken, but you have a course outline which will also tell you that. But what I'll do if that thing is broken is rush some videos for you. All right, I'll rush some content this weekend so that you have it. I didn't know it was broken. I assumed you could all see it. Sorry about that. Your timelines are blank. All right, this is literally the first I'm hearing of this. I had no idea. I just assumed you could see it all. I was so confused by your question. I was like, it's all there though. I don't know why it's broken. I don't put those time. Okay. I'll figure it out for you. I'm sorry, and I'll make you some videos because I think those timelines are a bad way to represent it anyway. So I'll make you videos. I'll share it with you. You'll know. You've got an assessment due in week 3, which is finish the quiz, at which point you'll be asked to write a report covering your content you've learnt in the first 3 weeks, which will be due 2 weeks after that. Then you'll get a quiz 2 weeks after that on report writing, and then you'll get weekly meetings with your workshop leaders. But I'm going to put all this in a video, and I'm going to send it all to you. I'll make it this weekend. I don't know why they're so broken. Okay, Sorry, I'll get that fixed. In terms of some of the other questions, Lachlan, should we account for cyclone durability in the chem renewable project as there is a distinct season for it? 100% there is. Do you need to be desalinating water in the event of a cyclone? Possibly not. Do you need a solution that is maybe portable so that it could be brought inside in the event of a cyclone? Possibly, yeah. So again, that's a thing that you might be able to build into your design that could be really, really good that somebody else may not consider. Regardless of if you're designing for cyclonic winds or not, having a good understanding of what weather conditions your device is capable of withstanding is really important, okay? Because I'm going to ask you about it. How do we check if we got 21 out of 21 in the assessment? You should be able to go to my grades. This represents differently for me as an academic, but you do not have any personal marks. I think you can check it in my grades, okay? If somebody can help out here, because I don't have a my grades, because I don't have grades as an academic, I think you can normally also go to the assessment, If you've taken it once before, you may be able to view previous attempts, and that should show you the grade you got last time. Are we meant to collect the robot stuff tomorrow or today? Today from 2 to 4. Also, does every individual person have to come and collect them? No, it's one person per team. I should definitely update that. Yes, it should be in the course outline as well. But again, course outlines are not the ideal way of necessarily grabbing that data. No, you're one. Okay, so am I supposed to watch the lectures beforehand? Yeah, 100%. That's why they go up on the weekend, to buy you that time to be able to watch the lecture before this session. So the issue. There's a few issues with online pre-recorded lectures. There's a few issues with online lectures in general. Is if you run them live and you have a technical issue, it's really bad. Like I dropped in the live stream last week. It was a live stream. We got over it. If I dropped in the middle of a lecture, really, really bad, right? So pre-recording is way better, and also it means I can do many, many takes, because it takes me like 10 hours to record that 2-hour thing, and then you get a good take. So you watch that on the weekend if you can, or on Monday if you can, and then you can come to here, and then we can do that engaging, hopefully, recap of the key points of the lecture, and you can ask me questions. You can go, I don't understand how models and assumptions fits in to my robot project. Can you explain that to me? Yeah, 100%. Let's talk about that stuff. So that's your, and then hopefully that happens before your workshop of the week. And then you can take that knowledge into your workshop and hopefully understand the things you're learning in your workshop. That's the dream. I understand that sometimes life gets in the way of that, but that's how you should be trying to set yourself up every week. Lecture, live stream, workshop. I also know there are 2 classes that come between the lecture and the live stream, but it's the best we can do. This is the self-assessment. The first assessment task is the self-assessment, yeah. Also, the ENGG1500 blackboard is blank. Really? Okay. See what I can do. Should we start on our report for our project? Okay. I wouldn't start trying to write your report yet. All you should be doing is learning the content of your labs. Essentially, what the report's goal is to do is to make you review the content of the labs and write down the key parts. Because by writing them down and explaining them to somebody else, it reinforces that knowledge in your own brain. That's the point of the report. Well, that's one of the 2 points of the report, but that's the main point of the report. So what you should really be doing weeks 1, weeks 2, and kind of week 3 is doing the workshop content. I don't tell you about your upcoming assignment because I don't want you thinking too much about it. That cognitive load is stuff I don't want you to waste thinking on an assignment right now. I want you to spend 100% of your cognitive capability on your workshop this week. Because if you can get the fundamentals down, writing about them is easy. If you don't get the fundamentals down because you're distracted thinking about assignments, the assignment is actually much harder. It's a weird cycle that you can get yourself caught into. But should you be starting? Yes. The way you start is you do your workshop really well. That's your goal. Okay. You can check it in my grades. Awesome. Thank you. I'm so behind on this. You can go to start the quiz and it'll show what mark you got last time. Awesome. I thought that was the hack. That's the hack I used to use. For the solar decel project, does our process of desalination have to incorporate solar? No. No, it does not. It's called the solar decel project. We give you solar. We don't give you another resource, but you do not have to use it. If you click on your name on the top right, there's a tab called My Mark. Really cool. Was that 2 to 4 or 2 to 6? 2 to 6. I may have misspoken. I have civil engineering classes in ES126 from 2 to 4 and then from 4 to 6. And I'm hanging out in those classes, not really doing very much. I'm just sort of chilling. So that's what I thought a good... I'll be sitting there on my laptop doing admin work. So just kind of come in. 2 to 6 is the window that I'll be there. You don't need PPE for this week's workshop, Lachlan. It would be great if you had it so you could get it checked. But yeah, you don't need it. Wait, so we can't get the robotic stuff in our lab? No, you can get the robotic stuff in your lab. I tried to explain it in the Discord. It may not have been clear, but you can get it in your lab. But you've got to do 2 tasks this week. Assemble your bot and do the lab. If you get the stuff in the lab, then you'll have to spend that time assembling your bot. You won't be able to pre-assemble it, which means you have to do the lab on your own, which is fine. There's absolutely no problems with that. Everybody who did their labs yesterday did that. It's fine. But if you want to assemble your bot first and then do the lab in the lab, come and grab your stuff from me. Doesn't matter, whatever suits your team. What room do we go to? ES126. It is hard to find. It will take a little bit of time. Oh, people are already answering it. Thank you, legends. Oh, it's you, Greggy. I was going to say, yes, it does mean you can watch the lecture at your own time, and you get to control your own learning. Yes, this is one of my colleagues. Of course he agrees. Yes, Storm, you're good. Free at 4:30. Come at 4:30. No dramas. Assignments can also be found in the course outline with due dates for 1003. Yeah, so your course outline should have everything. The banner is a thing that they added last year. It is superfluous to a course outline. Project brief for electrical is not up yet. I made some changes really late, and I want to get them correct before I upload them, because we are changing the focus of your end project a little bit this year. You will get them soon. How big is the final report expected to be? Is there a specific word count that we need to meet? There is a specific page count that you will need to come under. Nobody has an issue reaching the page count. You have a problem staying within it. And we will talk about concise communication when we do communication skills. Will we get turned away this week for not wearing enclosed shoes in the computer labs? If you can't have like thongs in the EE building in general. It's just an OH&S violation. Wear the correct footwear. Are you able to arrive early for the 8 a.m. workshop tomorrow to build the bot if you're unable to collect today? Probably not. You'll be okay. Don't stress about it. We'll try and get there as early as we can, but the building doesn't open until 8 a.m. So there's rules around if we want to have students in there outside of 8 a.m. to whenever the building officially closes, you need after hours access, and that's a horribly difficult process to get you out of hours access. So realistically, it's going to be 8. I'll stick around 4 to 6, 6:05. If you have a class today until 6 o'clock and you want to come 5 minutes after 6 to collect your stuff, I'll stick around for you. In software, you'll only be using Thunkable. Quite common in industry, a language is picked and you use that language within your company, whether it's the correct thing or not, it doesn't matter for your particular task. There are other constraints around which language you use. So, for example, Python that all of the people in 1003 learn isn't necessarily the language that you will use, but it's the language that the bigger group that you are a small part of has selected, and so you need to learn how to solve problems with that set of constraints. So in all of the projects that have a programming thing, a language has been picked, and that is a constraint of your project. So you are constrained to work within Thunkable. That's what your client has provided you. That's what you got to work with. And sometimes this is not the optimum language. We know. We don't doubt that. But it is a constraint, and you need to work with it. Is it preferred that we build the robot as a group? It is preferred. It's not absolutely required, but it's preferred. It's a good team building exercise. I like it as a team building exercise. Cool. As far as I can tell, I'm at the bottom of my list, but I'm sure I missed a lot of questions. I know that there were some weird bits and pieces, and some stuff. I know earlier, like half an hour in, I missed a bunch of questions. So please, if you have any more questions, chuck them up. If you would like to discuss anything, if there's anything that I need to remember to do this week, please chuck it in the chat and I'll add it to my list. Good session. Oh, also for the softwares, you'll get a pro Thunkable account, 1 per team, soon. I got them set up yesterday, so I think for next week, each team will get 1 pro Thunkable account. Thanks, Sean. Appreciate it, man. Oh, I need to make mods. I have no idea how to do that. Just gonna check what those messages are in Discord on my phone. I am paying attention to you even though I'm on my phone. I apologize. This looks super rude. There are certain things I don't like to pull up on stream, like my emails and stuff like that. So does the software have any inductions? Nope. Software's easy. No inductions. You are all good. Cool. Thanks for those in the Discord helping out people and answering questions for them. It's really appreciated. So basically, your in my office hours are 4 to 6 on Tuesdays down in ES126. Maybe I'm thinking about doing that. That's probably what I will do. I think that'll be the optimum. I think you've kind of read my mind here. I'm going to try it at least this week. The problem is there's no time in the entirety of the week when I know everyone is free. So I don't like setting this is my only 2 hours of office because some poor people are like, I've got a class at that time. But I'll probably make myself available at a time like that. Can first years get internship even if it's unpaid? Yeah, totally. Not that many people will take you on as a first year because there's not a whole lot you can do other than sweep the floor and get coffee for people. But some places will take you on. Not because they expect you to be super useful to them now, but because they can get you integrated into their company as a first year and then get you back as a second year, third year, fourth year, and you can add huge value to them then. So they essentially invest in students early, um, and can get you to work through. And there's absolutely nothing wrong with spending a bit of time sweeping floors and getting tools for tradies and stuff like that in your first year. It's really good experience. So if you can get that, go for it. It will almost certainly be unpaid, and that's fine. Get a couple of weeks experience doing that. Go back in your next year. Hey, I've had experience doing this, plus I'm now a second year student. Is there some higher level stuff that I can do? So medical projects, like robot projects, like anyone with an STM32, it's 2 boards per team. Okay? So did your team get 2 boards? If so, you're good to go. It's not one per person. For the aerospace workshop, is PPE required? It is recommended. It is not absolutely required. But please try to get it and show it to Sean that if everybody's in there, and not that we really need it, but we can be like sick, everybody's got all of their PPE, we're all good for next week. We don't have to turn anybody around because you showed up with the wrong style of safety glasses or something like that. And you can hopefully build a good habit of remembering every whatever day, Thursday, I pack this stuff and I bring it with me. But it's not absolutely required, no. Yes, the inductions are up. Hold on, I'll show you. Depending on which one you're talking about, Kira, are you what project are you doing? What induction are you talking about? ES126 or something else? Yes, ES126. I didn't even see that. Cool. Kind of to be expected, I suppose. Still heaps of people. All right. Um, is there anything else? We don't need to be here for the full 2 hours. I'm happy to cut this and let you all be free. I'm happy to sit here and continue answering questions, but does anybody have anything else they would like to know? Or have Yep, 126. Awesome. Hold on. I'll show you. All right. So go to Blackboard. Go to Blackboard. Bam. Go to my site. All right. So don't go to this. This is not correct. Well, I mean, this one will open, but you don't see anything. So don't go to that. Go to here now and go to the inductions tab on the left. You should only be able to see ES126. and then this is everything you need, okay? So that's the manual. It teaches you all the stuff that you need. There's 3 cool videos here for anyone who wants to watch them can watch them, and they'll give you a brief introduction to some tools and how to use them. They're really cool. And then the quiz is down the bottom. You need to get 10 out of 10 in the quiz, 100%, and then you should be good to go. No, look, I don't expect you to watch all the way. I'm not going to notify you of anything super important unless, like, I don't notify anybody of anything that comes out of these in reality, right? But yeah, like, I don't expect you to be here. If you don't have anything else to ask, it's all good. Okay, so all right, that's Blackboard browser stuff. I'll get that fixed. When should you start looking at industry experience? Generally, I would say second or third year is your optimum time to start trying to get industry experience. If you don't get it to the end, you don't get it to the end. That's okay. But if you can get some industry experience second or third year, hopefully it can contextualize the content that you're learning within your degree. We teach you some project management, and you get to have sort of seen some real world projects to go with it. Do we still need to record attendance for Monday 3 to 5 classes? Not at all. Just don't worry about it. It's a thing that we'll notice in your other workshop, but don't worry, your attendance won't be marked. I will take care of it through a separate system. Do not worry about it. Thanks, everybody. This was an awesome stream. I'm really, really happy with how this went. So thank you very much for your engagement. Thank you very much for your time. I'll stick around if there are any more of these couple of follow-up questions. But other than that, thank you. Be free. Have a good day. Hopefully I'll get to see you all in your workshops. Thanks, everyone. We don't have to check in for lectures. Nah, man, you're all good. No check-ins for lectures. It's only into workshops, and even so, yeah. No check-in for lectures. You're all good. Thank you. No dramas. Happy to help. Live streams are recorded, and they should just go up. So my YouTube channel, I think all the live stream stuff is public, so you can just Google ENGG1500, find my channel, go to live streams, and it should be there. It's a good point. You can also do that. If you join a YouTube stream late, you can just rewind to the start, and eventually you'll catch up. So if you do miss like some of that content, that's a really good idea. And then once we hit Q&A, you just catch up then. I'm gonna put that in. Do we have guidelines on what to cover in our final report? So largely it is your decision as to what you put into your final report. The projects are different from last year, so just looking at what they wrote is indicative but not super useful. As in, don't just because they put it in doesn't mean that you should. Um, but in general, those communication skills are something I'm going to teach you. Don't fret about what goes in a report yet. We need to learn why we write reports in the first place, and once we understand that, what goes in them becomes trivially obvious. So we'll cover it. You're going to get some content in week 4, week 6, again in like week 8 or 9. There's heaps. We'll prep you for that. By the time you get to it, you're gonna smash it. Um, if I can't print, who do I see? Probably 17000 IT support. Um, what what reason do you know why you can't print? Um, it yeah. Have you put print credit on? Um, and then if so, if you've got print credit on your account and you still can't print, it's probably 17000 IT support. Log a job with them and hopefully they'll be able to help you. Okay, so Isaac, with your thermal storage system, was it more beneficial to have more smaller pipes rather than one large pipe? If so, why? So, more smaller pipes are more expensive, but what they mean is if you've got a big brick of material, um, depending on the distance between your pipes, that determines how quickly you can move energy within your material. So, if you want to charge or discharge it really quickly, you either need it to move energy around within itself really fast, or you need lots and lots of pipes. Pipes are really expensive. So if you have something that can conduct heat faster, you can get away with less larger pipes, which reduces your system complexity, which is really, really beneficial. So most thermal storage systems have huge infrastructure. A lot of them, not probably most of them, but a lot of them have very cheap thermal storage materials like salts and rocks and things, and then really struggle to move the energy around within them, and so have very high infrastructure costs, containment costs, and heat exchanger costs. Some people, us included, have higher conductivity materials, meaning whilst the material sometimes is a little bit more expensive, the infrastructure that goes around it is cheaper, you need less pipes, and overall system costs are hopefully better. Or, inversely, for the same system cost, you can charge it or discharge it faster. You can get more power out of it. It's a really complicated multivariable optimization. It's a great question. Um, UFD, if your group's not going to build the bot until tomorrow, is it preferable to pick up parts today? Yeah. Look, if you're around, come and grab them, and then you've got them, and then you've got them. Great. But we'll have the parts in the lab. It'll take us 5 minutes to hand them out to the teams that don't have them. Much of a muchness. Whatever suits you. With your battery, not a battery. Um, it's fine. Is there a max rate of heat out? So the maximum rate that you can suck heat out of something is well, okay, the rate of heat transfer is dependent on your temperature difference. So how hot your storage material is, how cold your other thing is, generally a fluid, like a heat transfer fluid that you're using to extract the heat. And then the conductivity or the thermal resistivity between the two things. So it's how well your material conducts heat, how well it interfaces with anything like a pipe wall, how well your inside of your pipe wall interfaces with your fluid. And all of those things kind of combine to give you a total resistance to heat flow. In terms of the material needing to catch up, well, yeah, the faster it can conduct heat, the better. But there's actually a more complex term than thermal conductivity that's important, and it's called thermal diffusivity. So, thermal diffusivity is a combination of both the conductivity and the heat capacity. So think about it like this. I can have something like aluminium that can conduct heat really, really, really quickly, but it's so light that if I put a cold source on it, it'll cool down really quickly just because there's not a whole lot of energy there to take out. Whereas if I get something like copper, it's really dense, it's got a higher diffusivity, it'll it keeps up, so to speak, better, not only because it can conduct really well, but also because it has lots of energy available, so it's got more time to replenish, essentially. So the thermal diffusivity and the overall system resistivity are both really important. Really complex question. Really good question. We actually spend a whole heap of time doing computer models of this type of stuff. It's one of the reasons why I stress models and assumptions so much in this lecture content to you, because different people model that problem in different ways, starting with different sets of assumptions, and it can massively change the outcome. It's really, really important because we've done some modeling work with some different groups, and they start with a different base set of assumptions to us, and they've come up with some very, very different answers to how they think that these things will perform than we do. And we go back and we're like, yeah, you see this assumption you made here, that's not true. Everything you've done from this point is invalid. But, it's different opinions on correct modeling strategy. And it's also why we do experiments, why we build boxes and we physically test stuff, because that's got a totally different set of assumptions in it, and it allows you to validate your modeling assumptions. All right. Um, is there anything else anyone wants to ask? Yeah, so is a system more efficient with smaller pipes or larger pipes? The efficiency of your system doesn't work quite that way. And efficiency is based on your losses outside of your system. It's actually a different set of things you need to optimize. What matters more in heat transfer? Surface area or volume? So surface area, you don't transfer heat through a volume, you transfer it through an area. Um, but your losses are probably due to your external surface area which is a function of your volume. So these things aren't fully separable. Wouldn't high diffusivity also be a problem in that it would lose heat too quickly? That depends. You can generally limit heat loss through deliberately putting in insulation to the outside environment, and then you tune things like the speed at which you pump a fluid through something in order to extract the correct amount of energy. What you do in a lot of turbine applications, if we totally exit thermal storage and we look at a conventional thermal power cycle, so like a normal coal-fired one here, they have a boiler which heats up water and becomes steam, and they actually take it out of the boiler a little bit too hot. So they put too much energy into it, which is essentially the same thing you were saying, and then they spray a little bit of cold water into it to level it out to make it be exactly the correct turbine inlet temperature. But it's a horribly nasty control problem to balance all of that. With units, will we learn how to do uncertainty? Not with me, but in other classes you will. So uncertainty is really messy, and you will see it in different applications in different ways. So there's straight up statistic stuff that you might see, but there's also like the way the mechas and things deal with uncertainty, and the way the civils and stuff deal with uncertainty is all a little bit different. So there's second year modeling courses that look at statistics, risk, and uncertainty. There's actually a new one. They're getting a new one written to look as a second year course that you will do around statistics, modeling, and uncertainty. Okay. Um, is there anything else? I'm happy to just call it here. If we don't have any course related stuff, I'm more than happy at the end of every live stream to talk about some of this more broad picture stuff. Love doing it. But if we don't have any other course related questions this week, I'm going to jump back into doing some of the other bits of admin that I desperately need to do, like fixing banners and stuff, because apparently they're broken. So, any other course related questions? More than happy to help you. Otherwise, I'm going to end the stream, and we can do this kind of chat again at the end of the live stream next week and the week after and whatnot. Blackboard is probably broken, but I'll do my best to get some stuff fixed. That's fine. I can solve this stuff in other ways. I can post other things. Oh, none of your banners work. All right. I'll look at it. I'll solve this in two ways. I'll try and get Blackboard fixed, but I'll also just put all this content up in a different way. Thanks everyone. I'll see you all hopefully in your workshops, or I'll see you on the live stream next week.